Hello, folks. Welcome to Rational Science. I'm on the road. I'm at an Airbnb in the middle of nowhere, and I'm on a bed trying to see if I can get the show going today. Let me know if you're having problems listening to me, hearing me, and if you're receiving the images. Please let me know, okay, so that I can correct that if I still can. We're going to be talking about object today. What is an object? What is a thing? Turns out nobody in the last 10,000 years has ever figured out what a thing is. And you say, well, what do you mean? That's a simple word. It's like, we all know what a thing is, don't we? Thank you. And no, the issue is that no one ever realized what a thing is, especially the mathematical physicists. And part of that has to do with the fact that a mathematician who calls himself, I thought he was letting me know about something. We have to define this word because physics is about objects. You can't do physics without objects. Mathematical physicists never had to do that because what they do is not physics. They call themselves mathematical physicists, but the physicist part is too much, really. It should stay with mathematicians. That's all they are. And a mathematician has no use for objects, for things. He can represent them with a number, which is what they do, and that's what they put in an equation. So they had no use whatsoever for objects. They can't put the word elephant in an equation. They can't put the word cube in an equation. So what they do, they represent it mathematically. Whether it's a thing, length, width, and height, and they just take the measurements, or they use the mass, or how much time, or whatever this thing moved in, and that's what they're going to put in an equation. So they have no use for objects, and because they have no use for objects, all these years they thought that maybe they could figure out how this universe works on the basis of mathematics, that an equation is going to give them, for example, the grand unified theory or the theory of everything. And, the reality is there are no theories in mathematics. They call them theories, but the word is misleading because a theory is an explanation, and an equation or whatever the mathematicians do doesn't explain anything. You cannot explain with an equation. It's just a description. Okay, so let's move on here. What we do here, we call it rational science because it's we're proposing a new notion of what science is, and it's really a little bit closer maybe to Aristotle, but not quite. We're not saying that we have to introduce experiments to figure out what Aristotle did. Absolutely not. We're going to go over that. But the issue is that what physics is about, explaining how this universe works. That's what it is. We want an explanation. We want to know why something drops to the floor, gravity. We want to know how light does its magic. How does Mother Nature do this magic trick where she does, for example, the slit experiment or whatever. It doesn't really matter. Magnetism, how a magnet attracts another. All those magic tricks that Mother Nature does, we need to figure them out. And that's what we don't have today. We don't have a single explanation for any phenomenon where an invisible, intangible entity is involved as a mediator. Okay, and that's where we start. Okay, so what do we say is science? Very simple. Here's a definition. You won't find it in a dictionary, so please don't look. You'll find some nonsense that we've had for at least the last 400 years, if not the last 10,000 years, the notion that people have of science. And it's an irrational notion, and that's what we're going to go over first before we move into going into objects. Okay, so what is science? Okay, and here it is. Okay, science, rational explanations. Very simple, straightforward. You have to have an explanation, and hopefully it's rational. And people say, well, that's kind of too easy, too small, too short. Like, we need to put a lot more stuff there because it doesn't cover all the bases, or maybe it's too broad, or who knows, So people are not satisfied with that definition. They say, we want something more than just a rational explanation. And so we need to ask, what else do you want? I mean, what are we doing all this for? Aren't we trying to explain the universe, how it works? And first, let's introduce some testimony from people from the establishment. One person, I'm not going to bore you with it, but here's a fellow who tells you that it is a part of physics having explanations, because you'll hear a lot of these mathematicians say, no, explanations are not part of physics. That's philosophy, that's ontology, semantics, and we don't do that. What we do is equations. So let's make sure that we have at least one person who votes and says, yes, we do need explanations, or physicists are interested in explanations. And here he goes. Listen to him. Here goes.
What causes gravity? So physics, as you know, this is the type of question, what causes gravity? This is the type of question that keeps physicists up at night. Because physics is, among other things, as you know, the search for mechanisms, the reasons or explanations for why certain things happen the way they do.
Straightforward. We need explanations. We want to know how gravity works, how Mother Nature, Father Universe, does that magic trick. Okay, so I hope at least that sets the tone. What's the problem? The problem is that all we have from mathematical physics is irrational explanations. And so the question is that what science is about? What they do? And this is it. This is what they're saying. Okay, they're saying that science, or what they do, mathematical physics, is irrational explanations. Are you satisfied with that reply, that what they really do is irrational explanations, and we're going to call it science? We're going to have an equation, and it's going to be followed by an irrational explanation. Are you at peace with that? Okay, so that's the first question. And here you have some people. Here's that these people, what the mathematicians have done, they've abandoned explaining. Or they give you some explanation, they don't care. They don't care, because as soon as you criticize and say, well, that sounds irrational, that doesn't sound right, there's a contradiction in there, and you have a paradox, which they say it's good, and this is what they give you, and then they dismiss all that. Say, well, yeah, because you're asking for an explanation, and we don't understand how quantum works. We don't understand how gravity works out there. But here's the equation. Here's the description, mathematical description. And so the question, are we going to live with that for the rest of our lives and say, look, from now on, it's just going to be irrational explanations? That's what science is about. Are you satisfied with that? That's what you got to think about. And here's one fellow who testifies as to that. They have no explanations whatsoever. Here it is. Okay, this is Richard Feynman. He says, talking about the slit experiment, which is the one that gave rise probably to quantum mechanics, or one of them, right? We choose to examine a phenomenon, the double slit experiment, right? Which is impossible, absolutely impossible to explain in any classical way. When they use the word classical, it means rational, okay? They say they cannot explain it rationally, because this is what they were trying to do before the 19th century. They were trying to explain, the workings of the universe in a way that's understandable. And when they say classical, they say rational. And they're going to be doing now from now on irrationality. It says, and which has in it the heart of quantum mechanics. In reality, it contains the only mystery. Nobody can give you a deeper explanation of this phenomenon than I have given. That is, a description of it. In other words, he's not giving you an explanation. The explanation is rational. They'll tell you the particles at two places are at once, or that the wave collapsed and turned into a particle as soon as you saw it, or all that nonsense, right? And he's saying, look, I can give you a description, meaning I can tell you what's happening from a mathematical point of view. And he's going to use words like field and wave and particles, which ain't particles. That's what he's going to use to explain. But then he says, look, we don't understand it. We can only give you a mathematical description. That's the issue. Okay, here's another fellow. His name is Heisenberg. He tells us in many words. Let me get this one out of here. He says the following. He says, the most important step was to see that our language, okay, meaning we have the ordinary speech, right, the regular talk, right, and they're going to use that language to try to explain their math. That's the issue, right? That our language is not sufficient to describe the situation. And in such a world as the path of the electron, they are quite understandable in the ordinary realm of physics when you have to do with stones and with gas and so. But they are not really understandable when we have to do with electrons. Okay, so in other words, he says you cannot put the path of an electron, you cannot talk about it in normal terms. You have to do it with math, with equations. Describe the itinerary somehow, but you cannot explain what's happening, the interactions, because they're going to be using things, words like charge and particles which ain't particles, that they collide or that they send another particle. But none of these words have any meaning in ordinary speech. That's why people don't understand them. That's why they don't understand their own theories. So at the same time, we know that these words which we use for describing the experiment, describing, not explaining, right? That they have only limited range applicability. That these words, for instance, when applied to electrons, really don't mean much. Absolutely loved it. They don't mean much. Yeah, tell me. What they're saying, what this Heisinger is saying, we don't understand it. That's what he's saying. He says he cannot explain it in ordinary way that a normal human being would understand it. He cannot explain in those terms. He can explain it in a way, but it's an irrational way because they're trying to put their equations, their numbers, their values, their units into ordinary speech, and they can't do that. Mathematics is not the language of physics when you look at it from that point of view. You cannot explain the math that they do in ordinary speech. That's what he's saying. There's no translation. Lost in translation, there you have it. Okay, and here you have another fellow, just in case he puts the icing on the cake. His name was Max Born. Okay, this is what he has to say. He says, since the development of special relativity, theories using a substantial ether fell out of use in modern physics and were replaced by more abstract models. Quantum mechanics talks about particles that aren't particles. You would talk about space-time. In general relativity, it's it's not a thing, or like Stephen Hawking said, I cannot even imagine this thing. So he can't paint a picture for you what space-time is. But they use it because it's a mathematical concept. That's why they call it a mathematical object. So I'm now convinced that theoretical physics is actually philosophy. So yeah, when people say, hey, that doesn't sound right, they dismiss it, say, well, that's philosophy, that's an opinion, semantics, ontology, or whatever they want to call it. In other words, they immediately dismiss it. They say that that's not their line of work, that's not what they do. But that's what people want to understand. They want to understand how the physical world works, and they say, we've lost hope in understanding that a long time ago. Okay, so all we have is this. We have this thing called irrational explanations. Why? Because they move concepts around. That's a primary one. And they cannot explain the theory. In other words, they cannot make a movie of their theory, not with concepts such as energy and field. What are you going to put for a field? A football field? What are you going to put? So they cannot use their words to make an image of the mechanism, a movie of the mechanism, because they're mathematical concepts. And concepts cannot be translated directly into images. Okay, so what they do is they put some stand-ins in there. They put some things that make you believe that they're talking about objects. When they say energy, they transferred energy. Well, what was transferred? I don't see it. What went through by my eyes? What are you going to put for energy? What are you going to put for mass? What are you going to put for time? So this is the problem. They're using all these words that they've invented, which are mathematical terms, and they do not apply to science or physics. Okay, so some people say, well, Bill, just rational explanation is just too short. I think we need to put some more things in there because science is a lot more than just rational explanations. Is that true? And here you have one word that they use in almost every definition out there, and it's the word study. And they say science is the study of blah, 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 whatever. Is science a study? Well, because they see science as an ongoing process, right, of discovery, as they say. So we're forever studying, right? And they say you need to put the word study in there. You can't just leave it at rational explanations because, you know, what are all these people doing? They're studying, they're doing research. Don't we call that science? Well, no, science is only the little tip of the iceberg, the one that shows up and which has the explanation. Only that little piece is science. Studying, anybody can study it and not know anything, which is exactly the case in mathematical physics. They've been studying for 10,000 years. We don't have an explanation for the part we're missing is the little tip, the explanation, the tip of the iceberg. That's what we're missing. The rest, what's underneath the water, it's study, lots of study and no understanding. So yeah, no, study, we remove that. It's got nothing to do with science. We don't study in science. In science we explain. Okay, so there's the first word that flies out. You'll see the word study in the Wikipedia or wherever you look up the word science or any of the sciences. You'll see the study of. No, in science we do not study anything. Okay, you can study all week and get a 0 on the test. And so studying is not part of science. You can study all you want. That doesn't mean, you can't go into your dark basement and study and do experiments, all that stuff. You can study all you want. But when you come to the conference, we want an explanation. Only the rational explanation, the tip of the iceberg, is science. Okay? And so we remove study. Do we observe? Do we gawk, as I say? Is that what science is about? Observing? You observe the birds all day long, or a whole year, and they're putting their eggs in their nest and all this stuff. Does that mean you understand what's going on? That you can explain what's going on? And so this is another problem because people say, well, we need to do an observation, okay? Especially, for example, says, how can you do science unless you observed something happening, right? How can you do physics, for example, right? Without you seeing something happen. What are you going to explain if you haven't seen it? And so the first issue is you have the blind man, and he's the blind sage. And he can't see. He was born blind, so he didn't see anything, okay? And someone comes to him, okay, and says, what about this? Can you explain this? He's a sage. He's a smart guy in the tribe, right? And you want some phenomenon explained. Turns out the phenomenon never happened. It's a hypothetical phenomenon. So the fellow comes over and says, what if, and he tells him, what if a stone attracts another stone, right? How could that happen? How would you explain it? And so the sage begins to explain it. He didn't see anything. He did not observe it. The other guy didn't either. He's bringing up a hypothetical situation, and the sage is going to explain it. So it's only the explanation part that's part of science, not the observation, okay? And the other problem with the observation factor is that they introduce witnesses. They say, oh, did you observe? Right? Did you observe this? What did you observe? Did you make your observation? And so the problem with that is because now the person comes into the court and he starts saying, I observed. And it's like, well, we got to take his word for granted because he says he observed such and such phenomenon. Well, did he? Maybe his eyes failed him. Maybe he thought he saw something. And it's not what really is out there. So we're trying to explain phenomena without observers. Okay? We say, look, don't bring the witness into court. This is not law where you try to convince a jury of something. The purpose of observe, the way it's being used today, is that these people are saying, we observed it in the lab. And what did you observe? Did you observe particles? Is that what you observed? Or is the observation of particles, is that put in there by hand by you? Because you say, well, what else could it be if not particles? That's what we're accelerating, right? Well, maybe not. Maybe we're not accelerating particles. Maybe that's what he thought. He observed why? Because all these mediators, all these things that are flying around, right, that we think are flying around, they're invisible and intangible. Most of them are intangible, but almost, I would say all of them are invisible. I mean, what's the mediator of gravity? Is it particles? Did you observe particles when the pen fall to the floor? So why use the word observe if not to convince people that, hey, are you going to trust my testimony or not? Right? And so this is how they fit in their opinions where observation is concerned, where it doesn't belong, okay? Because they can make an assumption. They say, let us assume that gravity is mediated by particles. Let us assume that light is mediated by particles. Then we have an assumption. But when they say we observed, now they're just putting down your throat, shoving it down your throat, that they did see particles, that they did see particles mediate gravity and saw particles mediate light. That's the way it's used today. It's used as a weapon. That's why we eliminate the word observation as well from science. Okay, do we do experiments? Well, again, what's the purpose of experiments? It has two purposes. One is for the guy who wants to do research on his own. He does an experiment. He tries to learn something from it and come up with an explanation. That's okay. No problem. Nothing wrong with you doing an experiment at home. When you come to the conference, we want you to explain the mechanism, the causes. Okay? And these people bring the experiment and say, oh, here's my experiment. Give me my Nobel. No. No, hold it. You didn't understand your experiment. You got two magnets, one attracting the other, and you're saying you carried out an experiment. Should we give you a Nobel because you found out that a piece of metal attracts another one? A discovery, just an observation, a description of what happened? No, we need to explain the mechanism, the cause, what caused one magnet to attract another. That's when we shine, right? That's when we do science. Until then, we haven't done science. So we don't do experiments in science, okay? Let's make sure we understand that. Experiments is a tool that you use to try to figure out something. But it's the figuring out something that is science, not the doing the experiments. Yeah, you had Faraday. He used to do experiments at the Royal Society, and all he did was experiments. He couldn't explain a single one. So what was the point of him doing experiments? Okay, is it just to wow the crowd and say, oh, look, a magnet attracts another. Wow. No, it's not a show. Science is explaining. Okay, so no, we don't need experiments in science. You can do all the experiments you want at home. Just don't bring it to the conference. At the conference, we want to see, or hear, really, see and hear an explanation. Okay, do we use equations in science? Here's equations. Okay. Equations are descriptions. You haven't explained anything, so it's not part of science because science is explanations. What's the point of you describing something mathematically? Saying this is how fast something moved. Okay. Does that require, for you to be a rocket scientist? You have a clock and you timed how fast the lion ran. Clock him, says he travels at 40 kilometers per hour. Great. Is that science? Because you timed something. You let go of the pen, falls at 9.8 meters per second square. Great. Okay, so is that science? It's just calculating something based on units that you created. Again, measurement experiments, they don't tell us anything. They're just descriptions. And an equation is just a way of formalizing what you measure. And again, so it's just a description. So are we going to say that science is a description? You bump against the wall. Now there's an observation. There's an experiment. You bumped against the wall. I'm the first person to discover this wall. And I'll describe it. It's white. It's got 2 meters this way, 3 meters that way. It's solid, and this is the coefficient of the volume of how hard it is, whatever. Is that science? I bumped into the wall and I'm the first one to discover the wall. So these people are out there and they say, I discovered this phenomenon, I discovered this thing that happened. And again, a lot of that has to do with observation, where the person introduces his testimony as science. I'm the observer, I observed. That's one issue. The other issue is that, you bumped against the wall, so you found the wall. You're the first person to discover that there are rhinoceros in the world. So you get a Nobel Prize because you're the first one who came across a rhinoceros. Nobody believed in you. Nobody thought there was an animal with a horn, and you're the first one who brings it in or takes a picture of it, films it. And so is this science? The first person to discover an animal, a wall, or whatever? And so, when you use these equations, all you're doing is describing. You're describing what you measured, and you're putting it into numbers and units. Not science. Hopefully, science is a little more than that. Again, explanations. And here you have prediction. Is prediction part of science? People say, oh, you have to do a prediction. Well, prediction entered science through math, because if the car is traveling at 50 miles per hour, you make that assumption that it's traveling at 50 miles per hour in a straight line. Well, it starts at A. You say when 50 miles per hour, it's going to be in 1 hour, it's going to be at B. You make a prediction. Why? Because you already know, what's going to happen. That if it is constant with its speed and travels at this speed, in 1 hour, it's going to be over here at B. That's why they introduced description and prediction. Okay, so you can predict. So what? So you can predict that tomorrow there's going to be an eclipse of the sun, because you've measured many times how fast the moon is going and where everything is located. It said tomorrow at 3 o'clock in the afternoon, the moon is going to get in between the earth and the sun. And so there's going to be one, an eclipse, before it happens. You made a prediction. Does that make you a scientist because you've already observed in the past, measured, have a number, have an equation, and know it's going to be there? Well, if you can tell me why, then you're doing an explanation, not a prediction. Prediction is just the description and saying tomorrow it's going to happen. Okay, so far you haven't explained anything. Maybe it's out of the top of your head. Maybe it's just lucky guess, because I asked you, why is it going to happen? You say, well, I don't know, but it's going to happen. And you say, well, you should tell me why. How do you know that God? Do you have God's ear or something? Is he talking to you or something? And so, no, predictions, we don't care about predictions. We just care about explanations. We want you to explain why there's going to be an eclipse tomorrow. Okay, if you know why, you should be able to explain the mechanism. Okay, how about evidence? Okay, we have evidence and verification. What is verifiability or falsifiability, which is the same thing? Well, falsifiability is opinion. You falsified God for the atheist, but you did not falsify God for the theist. And so one guy believes, the other guy doesn't believe. And so what do we have? What do you mean falsify? Falsify for whom? So falsification is not part of science at all, because it's an opinion. And that's what evidence and verification, proving is. Who do you prove to? Did you prove to the Dalai Lama, to the Pope? Who did you prove that God doesn't exist? Okay, so again, you present evidence, maybe from an experiment, maybe an equation. And so you say, here's the evidence. Well, yeah, but your evidence did not convince me. If you don't believe that, you go to some of these court cases, and they present all the evidence to the jury, and the jury doesn't believe the prosecutor, believes the defense attorney, or vice versa. So the same evidence did not convince, one group or another. And so, evidence is, again, a question of belief, of opinion. And so that's not part of science. That's part of religion. So all these things, running an experiment, making a prediction, evidence, all that belongs to religion. Prediction only, it's just a description, okay, just like an equation. But evidence is belief. It's a question of belief. So we don't do that, in science. Okay, how How about persuading, convincing, converting, and recruiting? Well, that's tied into, again, proving, doing evidence, that kind of thing. Is that what science is about? To persuade you to believe, to convince you, to convert you? Sounds a lot like religion, not like science, if you ask me. And finally, we have, if we eliminate all those, we go back to square one, which is we cross them all out, okay? And we end up with this. There it is. We're back to normal. Okay, yeah. When you remove all these different things that people want to put into science, you end up with just rational explanations. Now, if someone out there thinks there's something more to rational explanations for science, I'd like to hear it. No problem. Let me know. I don't believe there is. I think it's just rational explanations. That's what people want to understand, how this universe works. I think that's what it's all about. Once we understand how this universe works, we're done with physics. There's no more physics after that. That's the end of physics, because now we understand how the universe works. We know how a magnet works. We know how gravity works. We know how light works, how the atom works. We're done. What else do we need? Explanations. And what we propose here, that science is divided into parts, two pieces, two branches. One of them is known as physics, and the other one's known as philosophy, okay? And we don't do philosophy here, but we just define it, saying that it's rational explanations of what? Reasons and purposes. We look at behavior, why someone did something. That's philosophy, okay? And again, if you look at philosophy, it's got all these big things that they put in there, ontology, semantics, a lot of stuff. No. It's rational explanation. It's a branch of science. It's a rational explanation of what? Of reasons and purposes. Why someone did something, behavior. What is physics? It has to do with objects, with things. Okay, rational explanation of causes and mechanisms. And you can only do causes and mechanisms with things, with mediators, hopefully, right? And so that's where we end science. We're saying that's what science is. And now we begin with what an object is. What is a thing? Okay, we have to identify the invisible mediators that produce the phenomena we see all around us. What causes gravity? What causes light, etc. So now we're going to look at that. And what's the problem there? Well, the problem is that for 10,000 years, no one has defined the word object. And so I realized that, that's the first thing I had to do. And when the issue here is that, I come up with a rope model of light and gravity. I can explain what you would call the gut or the toe, the grand unified theory, the fact that in one mechanism, you can produce light and gravity, which is the rope. At the same time that it holds two atoms together, right? You have a torsion going through that rope, and you can explain light. So with one mechanism, you have what you could call the grand unified theory, because this is a theory. It's an explanation for gravity and for light, for both. Okay, so that is a theory. But these people are looking for an equation, which even if they find it someday, which they never will, all they have is a description. Okay, so that's the problem. Okay, so what I like to say is that my biggest contribution to science, to physics, is not the rope model. I mean, I thought that was a good vision. I was very happy the day I discovered that. But this is my biggest contribution, the word object. I'm the first person to define the word object for physics. I'm not bragging here. I'm not showing off. I'm just saying it's a fact. Nobody in the last 10,000 years defined this word for us. Okay? And that's why, the mathematicians today who call themselves mathematical physicists, not one of them, not one can tell you what a thing is. And part of the reason that they can't tell you is that they've been using concepts, mathematical concepts, as physical objects for the last 10,000 years. And they never realized that if they're going to give an explanation of a mechanism, they absolutely need to introduce an object. So we need to find out what an object is. And so what do they say? Well, it says that it's that which you can see or touch. And that's the main one that they use. It's defined that way in some dictionaries. Others have different, you'll find the Wikipedia says it's made of It's what is made of matter, meaning it's made of objects, because that's what matter is. So you have these different definitions, but both of them are irrational. Okay, both of them are irrational because an object is not that which is made of objects. You haven't defined anything, and you can't use the see touch. Imagine, a single object in the universe. There's a single object in the universe. What do you want? Sphere? Okay, we'll put a sphere there. Okay, that's the only thing God created so far. He's going to create some more stuff, but the first thing he created was a sphere. Okay, so you have the sphere. God's out. He went back into his genie bottle. And so now you have a single object, and it's a sphere. So you can't see or touch it because you're not there. There's nothing there except a sphere in the universe. And so is that an object or not? I mean, do we need something else there? Do we need an object to hit it, to touch it, to see it? Do we need eyes? Do we need hands? Or is that sphere an object standing all by itself in the universe? And in fact, that's the way we do have to present objects in physics. A single object made of a single piece. All objects are made of a single piece. Tables, chairs, any word you can think of, the dog, the tree, the rock, they're all made of a single piece. Because all you're doing is pointing and saying rock. Okay? Rock gives no hint, the word rock gives no hint that it's made of many things. All you have is the word rock. And now the ET has learned the word rock. Okay, rock, I see. That's the word that you're using to designate that thing. So far, seems to be made of a single piece. Okay? And one of the things that creeped into the word object, which has messed us for 10,000 years again, primarily from those people who call themselves philosophers, it's that they think that it's anything that can be used as subject of a sentence, anything that is a noun, is a thing. It's an object or whatever. And that's not true. The word motion is a noun in ordinary speech. It's a verb in physics. You can't use the word motion as a thing. So you can't just translate and automatically, indiscriminately, move the words from ordinary speech into physics. You have to look and say, what does this word represent? And that's part of the problem with that, as we'll see in a minute. And we have all these religions that came up, the traditional religions, and because they couldn't see and touch the mediators, they created all these angels and spirits and ghosts. They had all these words which they introduced because they said, well, God must be acting here, must have sent an angel or the spirit or whatever. So we invented all these phantoms. And that's in religion, traditional religion. A lot of people still believe a lot of that, Then you have the Greeks, and they invented something even worse, the zero-dimensional 1D objects. You have the point and the line especially, right? Are those objects? Are those things? A 0D point, a 1D line? Is that a thing? Is it a concept? What is a 0D or a 1D thingy? We need to figure that out. And again, the Greeks invented that. And then the mathematicians of today, they invented concepts as objects, field and energy and mass. They treat them as physical objects. They bend the time. And what's worse is that they have this four-dimensional space-time. They say it's an object, a mathematical object, I guess they'll call it. Is it an object? Is it a thing? Is there such a thing as space-time? And no, it's an abstract concept, and it's a mathematical concept. They're talking about number lines, okay? So, four-dimensional whatever, it's really four-number-lined whatever. That's what it is. It's not an object, it's not a thing. And I think this is what prevented us from understanding the word object, a thing. And because we don't have a word thing, we don't have explanations for causes and mechanism. So don't be surprised if, a mathematical physicist cannot explain to you, a mechanism, a cause for gravity or for light or the atom or whatever. Why? Because they're not using objects, they're using concepts. And they're introducing them into mathematical physics, meaning into science, meaning to the public, because that's how it goes. You have all these translators, these magazines that bring down the math and put it, serve it in a gold platter to the public. And the public just says, well, I don't know anything about that. It looks fine to me. If that's what the mathematicians have come up with, I guess they're smart enough, they should know. And so they swallow this stuff because it comes through authority. Okay. So here's the big statement from me. Scientific definition of the word object destroys all religions. Takes 2 years for a person to understand what the word object means. And a lot of people skip that step and they say, no, I want to go directly to college physics. I don't want to do kindergarten physics. And they don't understand that until you master the word object, and you can't do physics. They don't understand that. And, it turns out that for the last 16, 17 years, I received all kinds of debates on the word object where people criticize, say, what about this? What about that? So we know the word object very, 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 very well. Okay, we're experts on the word object. When all these people come with ether and with plasma and with waves and fields and energy, we give them the run for their money. Okay, we show them that they don't understand kindergarten physics because they never went through kindergarten physics. They think, well, that's semantics. That's just ontology. What is that, philosophy? No, it's called the foundations of physics. Foundations of physics. You need objects to do physics. You better know what an object is. You cannot use the word plasma as a thing. It's not a thing. Neither is ether a thing. And all these dissidents who hate the establishment, they come with all these words. And and they don't realize that those words were put into their heads, into their mouths by the mathematicians who created those words to begin with. Okay, so they're using the language of the mathematicians to make their cases, and they're against the mathematicians. And so what we do here, we show them that we ask them kind of nicely. We use the word idiot. Idiot is a person who has big ideas. Idiot. Normal people have ideas. Rational people have ideas. These people have idiots, big ideas. And we show them that the reason they're idiots is that what they've been doing is using the language that the mathematicians, who they criticize, put those words in their mouths. They can't. They have to get rid of all the language of mathematical physics. All of it, completely. Erase it completely, because all of it is irrational, and the problem is language. Till you realize that, you don't understand what's going on in the world today, so-called physics, science, mathematical physics. You need to get rid of all the language that the mathematicians created, because what these people are looking for are explanations, mechanisms, causes. And they're using the words that the mathematicians put in their mouth. That's what's happening. Okay, so where do we start? Well, last week I showed this, the map of the world, how science progressed from 3000 BC, and those numbers are quite arbitrary, by the way. And we ended up in Greece about 800 BC, before Christ, right? And that's when the Greeks kind of formalized a lot of the concepts that we had over the centuries before they came around. Okay, they formalized it. They started doing a little more work on how to present this in an organized way. Okay, and so they started with geometry, and geometry was really the first, you could say, the first attempt at doing mathematical physics. The physics part was the measurement, the experiment, the land that you measured. And the mathematics, math phys, right? The mathematical part was the numbers, the relations. Okay, they created some standards. They said, oh, this angle is 90 degrees, and it's got a line here, a line there. They measured the lines. They started figuring out all these relations. And so we have two things. We have the mathematics and the physics of it. And it turns out that you can't put them together. Geometry is an irrational religion. Geometry has nothing that you can really sink your teeth in physics. Okay, it's pure math. It's pure relations, but they're using geometric so-called figures, right, to apply this math to. Okay, so they apply it to triangles, circles, spheres, cubes, whatever, and they're going to look at all these relations. But it's the relationships here that form the basis of geometry, not the thing itself. People don't always understand that. And so here we have a definition of geometry, the first religion of mathematical physics, the first branch, I guess you could say. Geometry, what is it? Land measurement. Why? They needed to measure the land to be able to put buildings and so on. So they started measuring and looking at orientation, how something compared with the sun or with the moon or with whatever, right? A branch of mathematics concerned with properties of space, such as distance, shape, size, and relative position of figures. Yeah, it's about figures. But as we will find out, lots of these, in fact, none of them are figures, okay? Because it's not the figure that ends up being part of geometry. It's the relations, the mathematical relations, which is part of geometry. None of them have to do with figures. They have to do with volumes, okay? And so we have to understand that. It's not about figures, but that's what geometry was supposed to be about. Okay, so here we have AI, and we ask them, what about Aristotle? He came up with all this stuff about, the geometric relations and so on. And here it is. He said the following. This is what he thought an object was, a thing was, which is what they're going to be using for geometry. It says Aristotle had multiple definitions for the term object, including art, in art, in perception, and in general. Okay, and there you see, what was he thinking? He was thinking that a person, an event, or an inanimate object were objects. Okay? An event is an object, a thing. Maybe a person is, maybe an inanimate object, maybe, but not an event. And what was it all about? Well, it was all about perception. There you see it. Aristotle divided objects of perception, and he had colors, sounds, and flavors, shapes, sizes, and movements, and whatever you perceived. And again, in general, that's what he came up with. He said it's got to do with perception, with our senses, with what you can touch or see specifically. Okay, so this is where we started, and he had the wrong notion, an irrational notion of what an object is. Okay, no, an object is not what you can see or touch, but this is where they formalized it in the Greeks and said, look, this is an object, it's what you can see or touch. And we just sped along, and since then been doing see and touch. So you ask anyone on the street, what's an object? That's what you can see or touch. And because you can't see the mediator of gravity, there's nothing there. Because you can't see the mediator of light, there's nothing there. And you have entanglement, one particle affects the other one, you can't see or touch what's ever in between, so there's nothing there. And then they worry about, relations. Was it instantaneous? Was there an immediate transmission of information? They get all this nonsense that's got nothing to do with physics. Okay, so here we have another fellow. He tried to do a little better about 100 years later, and his name was Euclid. And he has these two definitions, which are maybe the closest ones to the shape definition that I have, okay? And it says, a boundary is that which is an extremity of anything. And then definition 14 says, a figure is that which is contained by any boundary or boundaries. So he kind of went in circles with these two definitions, because he's saying a boundary is what covers an object, and an object is what's covered by a boundary. Okay? But that's not the problem. That's not the problem. He was close, not quite. He tried, okay? The problem is that no one ever used that definition. No one used that definition at all to this day. Okay, no one uses that definition. The definition is that which you can see or touch, that's one, and the other one is that which is made of matter. But none of these two definitions have ever been used. They just put them, Euclid put them there, everybody said, okay, I understand, which they didn't, because it's circular, right? But even if we could understand them as being, something related to shape, it was never used. The notion of object, meaning shape, has never been used. And again, it hasn't been used because the mathematicians have no use for objects, for shapes. Okay, that's art, or who knows what it is, Okay, and so what did we end up with? Well, we end up, because of the Greeks, right? Because of Euclid. And here you end up with, I asked the AI, again, R2D2 was around there, I asked them. So geometry is the study of property, la, 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 la. It's all about figures in geometry. But I like what the AI told me, and this, again, has to do with the mathematicians feeding the chat GPTs and all these bots that we have out there. says there are two main types of figures in geometry: two-dimensional, flat or plane, right? Figures. Three-dimensional figures like solids, right? That have, they said, depth, volume, and thickness. None of the three are dimensions. Okay. But then it goes into and says, it gives two examples. So some basic geometric figures, right? It uses the word figures, include points, have no width, length, or depth, and lines which extend infinitely in one dimension. I've never seen one-dimensional anything, or a zero-dimensional, because point has no length, width, or height. So we have nothing in front of us. So what's the figure that they're talking about? How come these are the figures that are the building blocks of geometry today? Okay, and again, they're not talking about figures. When they talk about points, they're talking about locations. But they don't use the word location, because if they did, it would be a qualitative concept, first of all, and second, they would not be able to put it in any equation. You know, it's a qualitative concept. And so, you know, you can't say, we're going to build a cube with locations. We're going to build, a circle with locations. No, you can't do that, because people say, what do you mean with location? You're going to build a figure with locations? And that's when it becomes obvious that, you know, what they're doing is talking about concepts and not about geometric figures. And the same with a line. You know, line is infinite. That means it's not, if it's infinite, you know, it means it's not an object, because an object is that which has shape. And whatever object is infinite is not an object, period. You know, because it doesn't have shape. It doesn't meet the definition of the word object. And if it's one-dimensional, well, you know, you don't have nothing in front of you. That's what it is. And I like the statement that the bot told me at the end. It says, geometry is important because it helps us understand the physical world. Yeah, sure. If you can make sense of it, yeah, maybe. No, it doesn't. Geometry does not help us understand. It just describes what relations of volumes. That's all it does. Okay, we're not talking about geometry. We're talking about volumes. And here's a corollary you can get from good old Euclid, and that's that, you know, he's got. Let me make this smaller. There it is. And Euclid defined in his book 1, a semicircle is the figure contained by the diameter and the circumference cut off by it. Okay, so we have a semicircle. You'll see it here in the center. There it is. That's a semicircle, right? And what he does in book 11, definition 14, he says, when a semicircle with a fixed diameter is carried around and restored again to the same position from which it began to be moved, the figure so comprehended is a sphere. So he's building the sphere with movement. Okay, he's taking something, twirling it around and saying, look, that's a sphere. It doesn't look like a sphere. It looks like a line to me, right in the center, maybe as the green part there, the thick green line. That's certainly not a sphere. And is a sphere something that rotates? Is that what it is? But this is how Euclid defined it, and he essentially built a sphere, which is supposed to be a figure, a static figure, you know, without any motion, and he's building it with motion. So this is the problem. This is the type of irrationality that entered mathematical physics, geometry. You know, they built everything with motion. Okay, so what is a circle? Well, they have all these rays. Euclid, they have all these rays to every point on the circumference. And what's the problem with that? Well, the problem with that is that there are infinite points in a line, because the point is a location. It's not a thing. It's not a dot. It's not a 2D or 3D dot. 2D point is a location. And you can put gazillions of locations between any two locations in math, because they're talking about numbers. And, you know, you can divide the number 1 as much as you want, infinitely, as they say. So the problem with Euclid's circle, that it's still being built. They're still building the circle, his circle, because there's so many points. He's got to draw all these rays from the radius to the edge, and on and on and on and on. And today they have a similar definition where they have all these points around, and they say that's a circumference that, serves as the boundary, right, of a circle. But again, they have gazillions of points, and whenever you have 2 points, just put another one between, and you'll never end, because they're talking about numbers, they're not talking about locations. Okay? So yeah, this is the kind of irrationality with which we started and we ended. We still have this. And one fellow says, one visitor here to the site, he says, motion is a property of matter. It needs motion to maintain form. That's what he said. This is what he was taught, or this is what I guess he came up with. I don't know. But this is what these people think. They don't have the ability to reason these things out. So they say, like water, which takes the shape of the container. Huh? Water takes the shape of a container? I don't think so. Where did he get that? Apparently he's still on Earth. He should fly with me to space. And there you see the astronaut. He had a balloon, and it had water in it. So he pops the balloon, and this blob is out there. It still hasn't disintegrated and turned into a little piece. He's got this single blob. And I take a snapshot of that. You can see there's the Earth and the moon in the background. Astronaut's flying on his flying saucer, whatever that is. And he pops the balloon. Here, this blob. I take a snapshot of it. Do you see any motion there? Do you see any container there? Where's the container? It's in space. Space is nothing. So there's no container holding the blob together. It's just a single blob. It's not moving as far as I know. I mean, maybe I have astigmatism. I don't know, but I don't see it moving. So I don't know what he's talking about. What he's talking about, container and motion, they feed nonsense into these people's minds, okay? And it says the fundamental substance takes the shape of its reciprocal momentums, which act like a container. Whatever. Water doesn't have shape. Well, it looks like it does have shape. I see shape there. Am I the only guy seeing the shape of water there? Okay, that's water. So I don't know what he's talking about. No, water does have shape. And it's not a question, what is the shape of water? Okay, the question is, does water have shape? Okay, so don't ask me, what is the shape of energy? No, does energy have shape? That's the question. It's a yes or no type of answer. That has shape, as far as I know. Correct me if I'm wrong, okay? Yeah, that does have shape. And just in case, we're going to put it in a Universal movie to make sure that, I'm still not drunk today, okay? There's the Universal movie, okay? Single frame, and we have the astronaut there with a balloon, pop balloon, and the water molecule, or the water blob, right? And as you can see, it fits into a single frame of the Universal movie. So there is no motion in a single frame of the Universal movie. All atoms in the universe are just at a given location from all others. That's all we see in a single frame of the Universal movie. And as you can see, it doesn't move. I would have to have 2 frames for the blob to move, to change form or whatever. Right now it has form and it hasn't changed, as far as I know. Okay, so please can let me know if it moves, if I've got something wrong with my eyes. I need to see an ophthalmologist maybe. Okay, is a cube, a thing? Well, here, I don't see it moving. Do you see it moving? Let me look. Doesn't look like it's moving at all to me, okay? And again, we put it in the Universal movie, and we see that it doesn't move. It can fit into a single frame of the Universal movie. So I don't know what this fellow is saying, that form requires motion. There's no motion there, and as far as I know, that has shape, form, whatever you want to call it. Those are synonyms in science, in physics. Okay, so much there. How about air? I mean, a lot of people get confused with air. I say air is an object, a thing. They say, you're crazy, Bill. Air is not an object, not a thing. Well, hopefully anything made out of atoms is a thing. Concepts are not made out of atoms. As far as I know, conscience is not made out of atoms. Love is not made out of atoms. Information, not made out of atoms. Because if it were made out of atoms, we could illustrate it and say, okay, it looks more or less like this. You can't do that with a concept. Intelligence, what is intelligence made of? Atoms? No, intelligence is a concept. Love is a concept, and so on. Energy is a concept. You can't represent them with, an image, because whatever you're doing wrong. It's irrational what you're doing. You're representing a concept with an object, and that's outlawed in physics. You can't do that. Okay, you got to put an object and call it an object. Okay, like the rope, for example. Rope is an object. Go to the hardware store, ask for a 2-strand rope. They'll give you, what I always show, and that's an object. Call it a rope. Everybody can point to it, knows what I'm talking about. That's the shape of light according to us, okay, of the mediator of light. How about air? Well, okay, let's see. Here's air, okay. Does air have shape? Yeah, by the way, it's similar to the astronaut with popping the balloon. If he had air in the balloon, there would be a blob of air, all the atoms coming out, and you look at that whole aggregate, and what you see is a blob, and say, okay, that has shape, the whole blob, right? Then it disperses, keeps moving, changes form, right? But any snapshot that I take of those atoms, it had better had form, right? And if you color code it, you can see it. Okay, so here's the air. Okay, and there you see air. That's what air looks like here on Earth, at least, right? And people say, oh, Bill, but you need the Earth. See, without the Earth, oh, I'm sorry. So I should remove the Earth. Let's remove the Earth so that people see only air. There it is. Got it? That's what air looks like. It looks like a ring. Really, it's spherical, so it's like a shell around the Earth. That's what air looks like. So air does have shape, hopefully. Okay, so people who say, oh, Bearbot, I got you. Air doesn't have shape. There it is. Do you see a shape there or not? It's that ring thingy. I can only put it in 2D. Okay. So yeah, air has shape. Water has shape. Everything made out of atoms had better have shape. Okay. In fact, kindergartners know that because, when they're drawing some landscape or whatever, they usually paint the air kind of bluish, light blue. And teacher asks, what's that? Says, that's the air. Well, how come you could paint the air? How come you gave it a color if air is not a thing? I can't color love. What am I going to put for love? A heart? What do I put for a point? A dot? Like they do in geometry? Okay, this same fellow says, everything other than the object itself is an abstraction of the object. An abstraction of an object. I don't know what he's talking about. You can only abstract it but never truly represent it. Because the only thing that can truly represent something or some verb is itself. Is that so? Uh-huh. Well, let's find out. Here's the Klingon. He comes to visit us from Klingon land. He's in another world. Comes to visit, and we try to show him our... we try to teach him our language. Okay, that's what we try to do. And so here we have good old Uncle Sam, right? And he's going to talk to the Klingon and says, look, see what I'm pointing to? Said, yeah. Table. Just one word. Okay? As you can see, there's no adjective in front of table. He didn't say that's the brown table, the green table, the big table, the small table. He just said table. No adjectives. There's no such thing as a dead cat in science, in physics, okay? Or live cat for that matter. There's only a thing called a cat. Okay, we don't put adjectives in front of the nouns, in front of the object when we present it to the jury, in the conference. Okay, say rope, tree, rock, one word, right? That's the beautiful rock. That's the ugly rock. No, none of that. We don't care about adjectives. And so people start asking stupid questions like, what is it made of? Who made it? How fast does it move? Where is it? How come I can't touch it? Does it exist? Table. It's that which has shape right there, right? That's called table. It's made out of a single piece. Yeah, but it's got two legs. It's made out of a single piece. The word table is a single piece. We don't begin to divide it and chop it up into little parts and say, well, it's made out of atoms and it's made out of molecules. It's got two legs and a... No. We just say table. That's how you present an object in physics. Made out of a single piece. We're not saying what it's made out of. We're not even relating to that. So you can't ask a million questions. Can you touch it? Can you not touch it? And this guy says, oh, but that's an abstract table. No. There's no adjectives in front of objects. So it's not an abstract or a real table. That's the word table. That's what a table is, what I point to. That's what I'm going to use in my theory to explain something. So I point to table, and then I use it. Okay, that's the way it works in science. Okay, you can't say, oh, but that's an abstract one. I wanted a real one. You know, the word table, when you look it up even in the dictionary, it doesn't say, oh, some tables are abstract and the other ones are real. No, it doesn't work that way. Table is table, table. Here in the land of the Klingons, it's always table. Table is that thing that I'm pointing to. What's it used for? I don't know. Maybe the Klingon sits on tables, for all I know. We don't care. Okay? That's what a table is. Well, that's what the word table represents. I don't care if it's abstract or real. And just in case, we put in the Universal movie, okay, you can see the table stands alone. There's no motion, doesn't change its form. Okay, there it is, table. Very simple. Every atom in the universe is at a given distance from it. And that's important, too, because, they say, well, well, I'm going to get into that in a minute now. Let me hold that thought. Here goes. Same fellow. He says the following. He says, I don't think plasma should be called a state of matter. State of matter. The mainstream say the sun is plasma, but what they mean is that it is gaseous plasma. Dr. Robichaud says it's liquid plasma. Well, first of all, Dr. Robichaud is not a scientist, okay? He's not a scientist because he's using the words that they shoved up his nose hole in high school and college. And those words come from the mathematical establishment. So he's still using the ancient language of mathematical physics, which is plasma, wave, field. He's using all these words that they fed him throughout his schooling. So you can't use those. You got to get rid of all of them completely. We have to erase all the language of mathematical physics, okay? Because none of them serve to explain how this universe works. So if you're wondering why they can't explain it, because they don't have the right language. It's a question of language. Language is absolutely important. So what is this plasma thingy, okay, that everybody talks about? I've never seen. I've seen blood plasma, that kind of stuff, but never seen this kind of plasma. But here it is. Plasma, wave, field, shadow, those are all concepts, okay? Does shadow have shape? People say, oh, shadow has shape. Well, not really. You take the box, you put it in front of the sun or the tree, maybe you put it out there and it has a shadow. You say, the tree has shadow, the tree has shape and the shadow has shape. But as soon as you take the tree into outer space, shadow disappears. Where'd it go? It doesn't have shape because it's not a thing to begin with. So you can't talk about a nothing that has shape, a concept. Shadow is a concept, okay? But concepts don't have shape, and plasma is what? Ionized gas. Look at the meaning. What is the meaning of plasma? Ionized gas. And unfortunately, we put another adjective in front of the word gas. Gas is a thing. Okay? Air is one type of gas, okay? You can say that's gas, and you see a blob of something. Let's assume some gas escaped from a pipe or whatever, and it's color-coded or it's black or whatever, smoke of some kind. You say, okay, that's gas. When you say gas in that context, that is a thing because it has shape. So you're saying gas. You could have called it air, or you could have called it, some other gas that you can think of, doesn't matter. But the point is, if it has shape, because all these atoms are together and you name that gas, you could name it X if you want, that's a thing because it has shape. Okay, and plasma is a dynamic concept because it's ionized. You can't take a snapshot of plasma. And here, let me prove that to you. Proof, evidence. Okay, let me convince you. Recruit you. Okay, here it is. There you have, hold it. Let me put this right. Give me a second here. Here it goes. There you have it. Okay, you have a single frame in the Universal movie, and they're putting motion inside, the single frame where there should be no motion. So that's where the problem is. These people are treating plasma as a thing, meaning you can take a snapshot of it. And I try to take a snapshot, but these things are constantly moving because plasma is ionized, ED, right? Ionized gas. And so something's happening to the gas, and that's why plasma is not a thing. It's a process. Okay. And, it takes, again, 10 years for all these people to go through all these little steps to show you what an object is, what a thing is. And this fellow says, he says the following. He says, which definition should I refer to? Did Kelvin or Newton define it? Who is out there acting as king of definitions? Who puts a standard? Well, the issue is that no one puts a standard. The way we do it in science, right? Not in religion. Religion, it's a question of people raise their hands, 50% plus one. That's the definition that everybody accepts because it was voted for. The majority voted for that definition. It's like voting for the flat earth society. 50% plus one, the world is flat, period. We're done. And this is more or less the same thing. No, that's not the way we do it in science. In science, you have to defend your definition. And people who have a different religion say, I don't like your definition. Good. Bring your definition. Let's compare notes. You criticize mine, I criticize yours. And let's find out where we reach with that. Let's see if you can defend your definition. And if it's painfully obvious that you have an irrational definition, some kind of contradiction, right? Then your definition has to be thrown out because you're not going to be able to use it in your theory. I'm going to be able to tear apart your theory because you started out with a wrong definition, an irrational definition, not a wrong one. Wrong is my opinion, but irrational is objective. We have objective standards for irrationality. Okay, another fella comes over, similar vein, here it is. You criticize the meanings cataloged in the dictionaries. Absolutely not a single definition of the ordinary dictionary survives into science because no one's ever learned how to define words, especially the word object, and the second word exist. Neither of those two words have ever been defined. And yes, the biggest problem in science is language, definitions. People don't understand it. They say, well, that's a semantic argument. No, it's laying the foundations of physics. You need to have definitions before you start to give me your theory. Otherwise, we can't follow you. And if you have a contradiction in your definition, as we will see in a second from the same fellow, then we don't know what you're talking about because you have these contradictions. Which definition are you referring to? Which notion? Okay. No one ever learned how to define words scientifically, rationally. Consistent. You can use them consistently, right? All definitions from ordinary dictionaries need to be revised before introducing them into physics. And there you have some examples. Object, field, energy, mass, time, plasma, all have irrational definitions. So if you don't know what an object is, if you don't know what plasma is, you don't know what ether is, then you cannot give your presentation. That's how simple it is. Okay, so this fellow gives us an example, parallel to what we're talking about, definitions, right? And he says the word state in the dictionary, condition, way of being. Okay, and there's a contradiction right there and then, but it also indicates primarily meaning there's more than one definition, right? Being still as opposed to motion or movement. Yeah, and this is the problem. The problem if you define it as being, whatever, way of being, that's a dynamic concept. But if you define it as a state, which is a static concept, then you have a contradiction because either you can fit condition or state in a single frame as of the universal movie, or you need more than one frame. You can't have it both ways. And these people have it both ways. They say, well, it's got many notions, and he says that in fact here says. In the dictionary, there are examples of use of the word in combination with others, okay? And so he continues, he says, for example, vibrational state means, right? Vibrational state. We already seem to have a contradiction because state falls into a single frame of the universal movie. Vibrational seems like requires more than one frame. So he says, the condition of, again, a contradiction, oscillatory movement. And so oscillatory, it's a condition of oscillatory. No, you can't have that. Either it's a condition, meaning state, or it's oscillatory and vibrational. So we have contradiction. Either we're talking about something in motion or something that fits in a single frame, a picture, an image, static image, right? And he said in linguistics it's called polysemy. The ability to have different meanings. In science now, you can't have many meanings for a word. And this is the problem. These people have several meanings, and you don't know which one they're referring to. And they introduce whichever one is more convenient for them during their presentation. And that's when they lose their audience, because maybe you were thinking it's a static concept. Suddenly it morphs into a dynamic concept, or vice versa. And so if condition is a way of being, that involves motion. We're talking being is always motion. If condition equals state, then we have a static concept. You cannot merge those two. Single frame in the universal movie in the case of static concept. And then the second problem he's got is irrational in science to have more than one definitions for a word. And this is where these people fail, because they don't realize that language is so important. And they just gloss over that and say, well, I looked it up in the dictionary. Throw your dictionary in the trash can. It's worthless in science. Not a single definition survives. If you're going to bring a word from ordinary speech into science, then you had better, and it's critical for your case, right? You had better define it in a way that it's crisp, okay, that we know exactly what you mean, right? Then we can follow your presentation. Okay, so what is the definition of object? There it is. We begin with the foundations of physics. That's what we do here. This is not semantics. This is not ontology. This is not philosophy. It's called laying the foundations of physics. And you need these things to give the foundations of physics, which is explanations of mechanisms, rational explanations. The golden principle, you can't do physics without an object. You absolutely need an object, okay? Because if there's no objects in the universe, nothing is happening. There's nothing to see, nothing to touch, see, or even to experiment or go to the lab and do something. No, you need objects. That's the first thing. So the first word you need to define in physics, in the foundations of physics, the word object. You need an object. What is an object? That which has shape. Shape is a universal property of all objects, right? All objects have shape, right? I don't know an object that does not have shape, but you're welcome to correct me, right? Space is its opposite. If a thing is that which has shape, nothing is that which doesn't have shape. And that's what space is, nothing, okay? Doesn't have shape. So it's not infinite, because only objects can be said to be infinite or finite, and hopefully all objects are finite. There's no such thing as an infinite object, and space is not infinite because space is not an object to begin with. So you cannot say it's infinite space. No, what are you saying? What are you talking about? What nonsense is coming out of your mouth? No, space is nothing. It's not nothing that which doesn't have shape. That's not the same thing as infinite object. Distance, separation between two objects. Location is the set of distances, right? One object to all the others, right? And that's one of the things about the word condition also, and that I should have mentioned earlier. But the issue is that people say, well, what do you mean by condition? Doesn't the condition change from one frame of the universal movie to another? You say, this is the condition in which I found the car after it crashed. So that's the condition. And they begin to describe it. They say, well, it's got its front fender bended, right? The windshield's gone. The metal is crashed. No, that's not a condition. That's a condition in ordinary speech. How do we do it in science, in physics, right? Mother Nature knows what a condition is. Condition for her, for Father Universe, whoever you believe in, is every atom at a given location in the universe. And so we have the car, and as far as Mother Nature is concerned, every atom of that car, whether it's bent or not, or broken or without gas, every atom of that car, that's the condition that car is in. That fits in a single frame. It's just every atom at a given location from all others for the car. That's condition. That's a state. That's the state of that car as far as Mother Nature is concerned, which is what physics is concerned about. The atoms that make something up and the locations of those atoms. That's the state. That's the condition. Now, when you talk about describing a condition of a car, you're talking about ordinary speech. It has nothing to do with physics. Okay, and then you have location, set of distances. One atom to all the others exist. Physical presence, meaning object that has location, right? I'm an object, hopefully, when I'm not moving. There we go. I'm an object and I have location, right? You take a snapshot and give it to God, a three-dimensional picture, he can look in there and say, okay, Bill is there, he's an object, I see a shape, and every atom of his body is at a distance from every other atom, including from God. If God exists, right? If he wants to exist, he better have location. Better be an object first. Motion, two or more locations of an object, and a concept. What is a concept? A word that invokes or embodies two objects. Okay, you need two objects. Why? Because it's a relation between two objects that someone is establishing. That's what a concept is. And with that, I will see